Hello everyone, I welcome you all in this class of science for grade 7th, and in today's class we are going to discuss about chapter 13, electric current and its effect. We all know that electricity is really very important nowadays. Apart from lighting the bulbs, we also enjoy the benefits provided by various electrical devices and appliances. And in today's discussion, we are going to learn about those devices, the various type of effects of electric current, and the working of these devices. So let's start with our first topic. Here you will find some electric components, their diagrams and their symbols. The first one is the electric cell, followed by electric bulb, a switch in the off position as well as an on position. You will find a battery made up of cells, and at last you will get the symbol of the wire and its diagram. Let's talk about a simple electric circuit. We all know that an electric circuit is made up of different components such as an electric cell, battery, switch, electric bulb and wire. These components of an electric cell can be represented using some symbols, and when these symbols are represented together, they form a circuit diagram also, that you can find on your right hand side, where the diagram is denoting closed electric circuit as well as open electric circuit. When you will find the discontinuity in the connection of the circuit, then we will say that switch is in the off position and the bulb connected to it will not glow. But when the circuit will be continuous and the electricity will be flowing through it, the bulb will glow and we will say that the switch is on. Now, as per the effects of electric current, they are divided into two categories. The first is called magnetic effect and the second one is called heating effect. First, see what is heating effect. When electric current passes through the conductor, the heat is produced, and this effect of producing heat is known as heating effect of electric current. Many electric appliances work as a result of this effect. For example, an electric iron becomes hot when switched on. This is because the current flows through the wire and produces heating effect. What is magnetic effect? When electric current is passed through a coil of insulated wire coiled around a soft iron bar, the iron bar behaves as a magnet, and this effect is called the magnetic effect of electric current. This is used in the electric bulb and some other scrapyards devices. Let's see how this heating effect of electric current works with an activity. So here you will see that a circuit is made and both the ends of the circuits are connected with two nails, and between the nails a nichrome wire is fit. When we will switch on the circuit, the current will start flowing and the nichrome wire connected to the nails will get heated. This shows the heating effect of the electric current, and this heating effect can be observed in electric heater, electric iron, electric room heaters, immersion heaters, electric kettle and hair dryer also. All these appliances have a coil of wire which is called an element, and when the electric current flows through the element, it becomes hotter, and due to the heating effect of electric current, it produces heat. This heat produced by the device in a wire depends upon its material, length and thickness as well. Let's see these factors. Length of the coil. The longer the coil, the greater is the heat would be produced in the electric appliance. The thickness of the coil. The thinner the coil, the more the heat will be produced in the appliance. The material of the coil. If the coil is made up of tungsten, it will be producing more heat when we are using copper as compared to it. So, these all are the factors which decide the amount of heat passing through or being produced in a particular electrical device. Let's see how this electric fuse works. We all know that electric fuse is a safety device and mostly used in the electrical circuits to protect the electrical circuits and appliances and prevents fire. Electrical fuse is used in all electrical circuits in the buildings. Electrical fuse has a wire which melts quickly and breaks when large electric current flows through a circuit, and it reduces the harm that could happen. Nowadays, we have started using one more device which is called MCB or miniature circuit breakers. So what is the difference between these two? The fuses actually work on the thermal and electrical property of the material. It means they depend on the electricity as well as the heat, whereas the MCB, miniature circuit breakers, work on the switching principle of electromagnetism. Now, in fuse, it does not give any indication that there is any overload, but the MCB will start indicating that there is the overload of electric current and the circuit could be harmed. In the fuse, it could be used only once it is broken, so you need to change the fuse after one use of it, but MCB circuit breaker can be used number of times. Fuse can be used for protection against power overloads, whereas the MCB provides protection against power loads as well as short circuits. So it is actually very beneficial. Fuse works on the automatic operation and MCB can be controlled manually as well as with automatic operations. The fuse are very cheap in cost, whereas the MCBs are high in cost there because they can be used multiple times. Can you recall what you studied about magnets in last class? You know that magnets can attract certain substances such as iron, and till now we have studied electricity and magnetism separately. However, now you will understand that electricity and magnetism are closely related, and this could be studied in the magnetic effect of electric current. So this was first noticed by a scientist named Hans Christian Ørsted in 1820. When he was demonstrating the heating effect of electric current, he noticed that a compass needle lying close to it got deflected, and just to check whether it happened because of the current, he reversed the direction of the flow of current by interchanging the positive and the negative terminal. And then he realized that the magnetic needle deflected in the opposite direction. And in this way, the magnetic effect of electric current introduced. And due to this magnetic effect of electric current, a coil of wire carrying current produces a magnetic field around it and starts behaving like a magnet. This can also be observed by this activity which is shown. Here we have taken a cardboard tray of a matchbox and then we have wound an electric wire around it. Also, a small compass needle is kept inside the matchbox. When the switch is on and the current is allowed to pass through the circuit, the compass needle gets deflected, and it shows that the electric current flowing through the wires make it behave like a magnet. So what are electromagnets? Electromagnet is a device that acts like a magnet when an electric current is passed through it. It loses its magnetic properties when the current is switched off in the place of a single loop of electric wire, as we can observe in the following activity. Here what we have done, we have taken a piece of wire and stripped the insulation from the two ends, and then we have wound the wire around the iron nail and connected the two ends of the wire to the two terminals of an electric cell, and this way we have formed an electromagnet. When we will bring some pins to it, these pins will get attracted to the iron nail, and we reach to this conclusion that passing an electric current in a coil wrapped around an iron piece makes the iron piece magnetic, and hence it starts behaving like a magnetism. And when the electric current will be switched off, the nail will lose its magnetism. Now, let's see how it looks like. If you will observe the picture, the whole electromagnet can be seen, where it consists of a solenoid wrapped around an iron core and attached to a source of battery with some wires. What is solenoid? So a solenoid is a coil of wire wound on a cylinder that has a length that is large compared with its radius. We can also say that a solenoid is a long wire that has been wound many times in a tight coil around a hollow or solid core. It is cylindrical in shape and it is often used as an electromagnet. So let's see where these electromagnets are used. There are various types of uses of electromagnets, like in electric appliances, scrap yards, and to lift some heavy objects. If you will find these objects in the scrapyard, you will observe that they are used to separate iron scrap from other materials in metal scrapyards. Also, they are used in the bullet trains where the magnetic effect of electricity can be seen. Now, how does it work in the electric bell? So, we all know that electric bell works on the magnetic effect of electric current, and it is also an example of electromagnet. This has a horseshoe shaped electric magnet, soft iron strip, contact screw, hammer and a gong, as you can see in the image. Now it works on the following step, like when the switch of the electric bell is pressed, the current starts flowing through the circuit to the electromagnet. This electromagnet attracts the soft iron strip and it moves away from the screw. This causes the hammer to strike the gong. As the iron strip moves away from the screw, it breaks the circuit and the current stops flowing. Now the electromagnet loses its magnetism and the soft iron strip comes back to its original position and makes contact with the screw again. This completes the circuit and the process is repeated as long as the switch is pressed and causes the hammer to hit the gong repeatedly. And this way, the sound of electric bell is heard and the working of an electric bell can be understood. I hope you understood this. That's all for the day. Enjoy your day. Thank you. Have a nice day.